Great, so here in Greenbuild, 2013 in Philadelphia, Siemens partnered with McGraw-Hill to introduce a new research study really designed about understanding the deployment and specification rate of emerging technologies. In green buildings today, buildings are getting more complex. Owner requirements for energy conservation and sustainability are getting broader and broader. What does that mean from an adoption of new technology? So our research really looked into that. But what it really showed us at the end, what it's about how technology is deployed throughout the life cycle of a building. You can have the best new technology put into a building, will save a lot of energy, save a lot of greenhouse gases, help with LEED credits and points, but in the end it's about how that building is operating. How are we using that technology to advantage it, and do the building operations and staff people understand how to maintain that technology so you maximize the savings and the benefit that you designed for that throughout the life cycle of the building.
So I just want to introduce a few of the key findings that we found in research that McGraw-Hill Construction just did with Siemens Building Technologies. And a couple of the things that we took out of the findings that were particularly compelling are that we are seeing different specification rates happening along the technologies that we investigated, and what that sort of suggests to us is that sometimes there's been education and awareness of how those technologies perform and pay back and how they integrate with the systems in the buildings, but there's other ones where we just don't know that case. And I think it's interesting for us to be able to delineate that specification and how it's moving forward in order for us as an industry to kind of motivate change and push the industry continually. So what the research was compelling to us was that there is the need to educate, there is the need to have an integrated team that goes in and looks at buildings in the first place in terms of the products, the technologies, and the systems, but also it's extremely important for the engineer to continue to be able to understand the performance of that technology and continue to have that relationship with the owner as that technology gets put into the building and gets operated in order to maintain and get the paybacks that they're expecting or helping to justify the investment in the first place. And what we found is controls are extremely important in that, as well as that relationship, because then it gives more fodder for the engineer to be able to increase the amount of work that they're putting that technology or specifying that technology in the future.
What's interesting to me about new technology and the adoption of new technologies really is the importance of context and of understanding the setting that the technology is moving into, because any technology, no technology is better in all circumstances. Some are appropriate or not appropriate for particular circumstances, so it's very important to understand the setting, to choose the appropriate technology for the particular application, and then to make sure that it's not just the specification, but also the installation, the commissioning, and the follow-through through operations that are really done with knowledge and understanding of the specific idiosyncrasies of the technology. So often we see really promising new technologies get a black eye, get tarred with, oh, that doesn't really work. It's not the technology's fault. It's the fact that people employed it as if it was the same as the old technology and didn't take into account the many ways in which it needs to be either installed differently or maintained differently or operated differently to really take advantage of what it has to offer.
Yeah, what we're seeing in Seattle is high performance buildings that are being judged by how they are actually performing. And an example is Federal Center South, where it's the home of the Army Corps of Engineers, and an actual 0.5% of the contract value was retained. And the design build team has been working to measure that and verify that result. One of the things we've heard at Greenbuild is the importance of measurement and verification. And one of the projects in Seattle that we've been a part of is actually tying those results to financial reward, where 0.5% of the project, of the contract value, was retained until that is actually measured and verified. Part of the design build team, WSP and ZGF on the design build team, are required to actually verify that those results are achieved. And we're 3/4 of the way into that measurement and verification, and 80% of what was retained has been awarded to the project. The Federal Center South project, which is the home of the Army Corps of Engineers, utilizes ground source heat pumps, it utilizes thermal storage, it's utilizing heat recovery as well as rainwater harvesting, and it's estimated that up to 430,000 gallons of rainwater will be harvested annually. We get a lot of rain in Seattle. In Seattle, we're seeing building owners that are actually requiring performance verification. So an example of that is Federal Center South, the new home of the Army Corps of Engineers, where the owner retained 0.5% of the contract cost for 1 year after building occupancy. We're into the third quarter, and 80% of that has been released, but a lot of people ask, how do we really tie and connect the design build team with actual energy performance? And that's been difficult to do. In the past, it was really design a building, look at some energy models, build it, and then get the plaque and put it on the wall. But now we actually have financial incentive to drive true energy performance.